Let's consider matrix A equal to this matrix. Consider the equation x prime equal to A times x. We need to find the general solution xt. This is x is function in t. First, we find eigenvalues of A. We have lambda equal to -1, multiplicity 3. And now we find the eigenvectors for lambda. A minus lambda I times v equal to 0. A minus lambda I minus lambda, so plus 1. We could have 1, 1, 2, minus 5, 2, 7, 1, 0, 0, 1. We can use Gauss elimination. 1, 1, 2, 0. 3. 3 and 0 minus 1 minus 1. The last two rows are multiple of each other. The first row we have 1, 1, 2, 0, 1, 1, 0, 0, 0. We can eliminate this 1, 1, 0, 1, 0, 1, 1, 0, 0, 0. We think of that as V ABC. We could have ABC equal to 0 here. A plus C 0, B plus C 0, and C is free. We need to make sure that the vectors V are non-zero. We have A equal to minus C, B equal to minus C, and C is free. ABC of the form minus C, C. We have C minus C, 1, 1, minus 1. So V is 1, 1, minus 1. Because we can choose multiple of that as long as C is not 0. We have an eigenvectors V for lambda. We have one actual eigenvectors. We need to generalize eigenvectors. So in this case, our matrix A is 3 by 3, lambda defective 2. So we know that A minus lambda I could be 0. And therefore, we will start by this one method, for method 1. Try to find the generalized eigenvectors V3, V2, and then rebuild the actual one V1. Eigenvectors V3 satisfy A minus lambda I curve V3 0. A minus lambda I could be 0, so V3 can be chosen to be any vectors. We need to make sure that V3 is independent from the actual vectors V. So V is this 1 minus 1, choose v3 to be 1 0 0. Now we build v2, a minus lambda I v3, a minus lambda I, this matrix, v3 is 1 0 0, so we have the first columns of I minus lambda I, 1 minus 5 1, and we have v1 is A minus lambda I times v2, A minus lambda I. So we do need to do computation here. One times 1 times 5, 2 minus 5, 10, 7, 1, 1. 3 minus 2 plus 2. This is actual eigenvectors. And then we have v1 is this, and 2 generalized on v2 and v3 1 0 0. With that, remember that's lambda equal to minus 1. The first eigenfunction we can call is x1 t, v1 e lambda 1 t to lambda t. So this v times e lambda t. Second one, x2 v1 t plus v2 e lambda t. Just remember that this one prime equal to this one. Then we have the last one, x3 1/2 v1 t square, v2 t, and v3 is lambda t. The general solution. So again, if we have this one prime, we get this xt c1 x1 c2 x2 c3 x3, and you replace x1 to 3 by the one we got here, v1 e lambda t x2 and x3. We can pull the e lambda t out because every term is with that. Put all this v1, v2, v3 lambda equal to minus 1, we get the solution. Okay, that's method 1 if we construct a generalized one like this. Method 2, we use for example, we use a formula right here. Since we have v1 equal to v here, 1 minus 1, we can find v2, and then from v2 we can find v3. So So find the solution of the equation, this one and this one. So that's the second method. But I guess for this case, when we know it's defective, missing two eigenvectors, we know that a minus lambda I cube equals 0. This one could be easier. This 0 is a 0 matrix. It would be easier with this way to find V3 and V2.